What is up, Algebra 2? Topic number 2 here for the midterm. This is simplifying and rationalizing radicals, everyone's favorite. If you do not already, go over by the sharpener and go grab a chart of the perfect squares. Yours is nice and long and thin. I have this one to fit on my screen, but it has your factors 1 all the way up to 20. Okay. It is extremely helpful, and yes, you will get to use one on the midterm, so no worries. So let's write topic number 2 at the top of our page, number it, put our name on it, and write down our topic. Here we go. Okay, simplifying radicals. We're going to use our calculator a lot here. The goal here is we have our list of perfect squares, and we are going to try to figure out what perfect square, that is, what number in my list out of all of these numbers, my perfect squares, which of these can I divide 174 by? Now, there's a couple tricks we can use. First off, we know for a fact it cannot be bigger than 147. So that means we don't have to try any of these numbers that are bigger than 147. Another good trick we can do is if we type in 147, and we divide it by 2, we know that this first number we can divide 147 by 2 gives us 73.5. So that means we can erase our list all the way down to the first number smaller than 73.5. That means I need to check 64 and down until I find the one that works. I'm always going to start at my highest number and work my way down to the lowest. So let's try. We're going to first try 147 and divide it by 64. We're looking for a nice whole number. Gross, yucky decimal. It can't be 64. Next one, 147 divided by 49. And boom, I get a nice whole even number. This means that 147 can split up into 49 and 3. So I'm going to take my square root, and I'm going to split it into 2 new square roots. I'm going to split this into 49, and the number I got, 3. Once it's all split up, one of your numbers should be a number from your list. So one of my numbers is 49. This is a perfect square, and it is in my list right here. The square root of 49 is 7. That means I can rewrite the square root of 49 as 7. Square root of 3, it's not in my list. 3 is not a perfect square. It's between 1 and 4. This can't be simplified. So it's going to stay exactly how it is. Square root of 3. Now, there's nothing else I can do. I can't divide 3 by any of my numbers in my list. So I am all done. One example done. Okay, let's try another one. 2 times the square root of negative 68. Now, I got a little cheeky here, and that's because we have this negative. Now, we are not allowed to take the square root of a negative. If I try, which the negative is, or the square root is this blue button right here. If I tried to take the square root of a negative, any negative number, and click enter, I get non-real answer. And what that tells me is I'm going to have imaginary answers. So, right away, whenever I see a negative inside my square root, I'm going to take that negative out and put an I out front. So I'm going to rewrite this as 2I. And now I get to make my 68 positive. Now I'm going to do exactly what I did in the first example. And I'm just going to focus on my 68. So I know that if I take 68 and cut it in half, I know that my perfect square has to be smaller than 34. So I need to check 1, 4, 9, 16, 25, and I stop because 36 gets bigger than 34. I always start at my lowest and work my way to the smallest. biggest down to my smallest. So let's try. 68 divided by 25. Does not work. 68 divided by 16. Does not work. 68 divided by 9. Does not work. 68 divided by 4 works. 68 can split up into 4 and 17. So I'm going to split 68 up into the square root of 4 and the square root of 17. I also can't forget this 2i is still being multiplied out front. From here, if you did everything correctly, one of your numbers is a perfect square and should be in your list. So if I look over to my list, I see 4 is one of my perfect squares. The square root of 4 is 2. So I can rewrite 4 as just a 2. Look, when I take the square root of a number, it goes away. Now 17 isn't in my list, and I can't divide 17 by any of my numbers. So 17 stays inside our square root. Now, what am I going to do with my 2i? Well, it's still here, and it's being multiplied. So I need to multiply 2i by 2. I can't multiply these numbers by a square root, but I can multiply these two. 2i times 2 is 4i, and the square root of 17 stays left behind. And I'm done. This is a simplified radical. 17 can't be broken down. I got my negative out as an I, and my 4 out that was multiplied with the 2's, and these are both simplified radicals. You will have two problems, one multiple choice, and one where you show your work of simplifying radicals. Make sure you have this all down. Feel free to watch it again. On to the next. Finally, you're going to be asked to rationalize a radical. Rationalizing is a process where we're getting rid of radicals in the denominator because radicals are never, ever, ever allowed to be in the bottom of a fraction. But we have a nice trick to get rid of this. To get rid of a radical in the denominator, we're going to figure out what that radical is. In this case, it's negative 12, or square root of 12. And I can get rid, as long as I multiply this fraction by the square root of 12 on top and the square root of 12 on the bottom. So I'm going to multiply the top by the square root of 12, and I'm going to multiply the bottom by the square root of 12. So I'm going to make sure I multiply straight across. 2 times the square root of 12 is just 2 square root of 12. You can't multiply a normal number and a number and a radical, so we just squish them together. 2 square root of 12 over, now we can multiply two radicals, and if I go to my calculator and multiply 12 times 12, I get the square root of 144. So we've multiplied by the denominator, the root 12 over root 12. We multiplied straight across. And now you'll see that what happens is 144 is in my list. It's one of my perfect squares. The square root of 144 is just 12. So I'm going to rewrite this as 2 square root of 12 over 12. Now, there's only one thing left to do. This is an okay answer. It's not a perfect answer. And that's because I always have to take a look at my square root and see if I can simplify it. Now, 12 can be divided by one of my perfect squares. Okay? 12 can be divided by 4. So I'm going to do what I did in those last problems. I'm going to take this 12 and I'm going to split it up. I'm going to split it up into 4 and 3. 12 is still on the bottom. The square root of 4 is just 2. So I rewrite it as 2 times 2 square root of 3 over 12. Last but not least, I multiply my normal numbers. And I get 4 square root of 3. Oop, my mouse is acting funny. 4 square root of 3 over 12. Now, this is a good answer. Can you figure out what you could do better? So if you said math, enter, enter, you are right. This 4 and 12 can be simplified. If we type in 4 divided by 12 and hit math, enter, enter, this actually simplifies to 1 over 3, 1 over 3, and we still have the square root of 3 on top. Both of these are good answers. This one's better, though, and makes me super happy. All right, that's your second topic, all said and done. Make sure you flip your paper over after you've gotten all your notes down and start working on those practice problems. Tokar's out of here.